All right, I guess we'll get started then. Since it's 7 a.m. my time, that's about right. So hello everyone, good morning, good afternoon, good evening, wherever you're joining from. Thanks for checking out the session on working with the AWS Cloud Development Kit to define and manage cloud infrastructure. My name is Steve Roberts. I'm a developer advocate at AWS, where I specialize in .NET and PowerShell, and currently speaking to you from a very dark Seattle area, about 7 a.m. So let's get started. Almost in the right place. There we go. All right. So today, nice and simple. We're aiming to cover a basic intro to just talking about what existing infrastructure as code techniques we've done before in relation to AWS primarily, how we've used things. Then we're going to introduce the AWS CDK or Cloud Development Kit and explain what it is, what it does, how you work with it. And then I'm going to head off into a couple of demos to show you how to work with the CDK. The first one to get you comfortable working with the command line tooling inside the CDK, and then a slightly more involved example to follow up using .NET as our technology stack. Feel free to post any questions in the chat room. My colleague Bill is monitoring the chat. If we don't get to any questions or there's something more involved you'd like to talk about, visit us in the partner AWS booth afterwards, and we'll follow up then. Okay, so declaring infrastructure. What have we done before or up to now? Well, many people have used consoles. For example, the AWS Management Console. The problem with web consoles or apps for doing this is it's hard to repeat exactly without writing things down or standing over someone's shoulder showing, hey, click here, enter this here, and enter this particular piece of data to replicate infrastructure. Sometimes even both. It's great for learning your way around, but it's not hugely practical for real-world infrastructure setups where you're launching untold amount of resource in the cloud. So not a great start. What about a templated approach? Well, as a developer, I didn't code in JSON or YAML all day, and JSON and YAML are the two template languages supported by CloudFormation. That's our infrastructure provisioning service. I mean, I don't know about you, but I just don't code in those all day. And what I found was that context switching between JSON and YAML and the languages I was working in, C#, PowerShell, it was actually pretty draining. It was almost as bad as, colleagues walking up during the day and saying, hey, let's chat about XYZ problem that I have, or did you see the game last night on TV? It took a while to get back into that mental mindset when I was switching from the template language back to the code I was working on, and then back to the template. The other and probably more serious problem with templates is that they have minimal expressiveness. So there's no looping, for example. Let's say that I want to stand up just a couple of VMs. I have to copy and paste the various infrastructure settings for those VMs to get those couple of resources. Or I need to resort to additional resources. For example, on AWS, I need to launch an AWS autoscaling group for EC2 VMs, even if I only want a couple, because that's the more convenient way of saying, hey, give me 1, 2, 3, 4, 5 VMs, etc. The conditional support inside templates is somewhat limited and awkward to express as well. If I want to do launch a particular resource, if some condition is true or false, the syntax is there, but it's not hugely approachable. There are some expressions in there that allow me to build strings or compose names of resources. Again, it's awkward, it's hard to recall. And frankly, every time I had to do it, I had to go and resort to the docs to remember how to do the various functions. Templates also have a limited sharing capability. Now, sure, you can share the entire template, but if I'm working with a particular component that I just want to share just that component, I'm back to copy and paste it. It's not great. Embedding any scripting can be difficult in templates. So when we launch an Amazon EC2 virtual machine, we can specify what's called a user data script to configure that instance. And I'm going to show you an example of that later on. Trying to put that script, it can be PowerShell or Bash script, whatever you need, inside a template and then escaping all of the quotes, the backslashes, etc. That can be really awkward and error prone. And the final problem with templates that I found is that it's somewhat inflexible if you need to reach out into your existing environment and do resource discovery. For example, reusing existing resources that you've launched previously inside the cloud, get those IDs. There are ways of doing it, but it's a little bit kludgy. But that's not to say templates are bad, right? They are reasonably simple and straightforward. And with modern editing environments, we get intelligent suggestions to help us as we're coding those templates. So that's not to say they're all bad, but there are better ways. And the third way that we've previously declared infrastructure is to code against the low-level service APIs. Now, all AWS services expose an API, and we then multiple SDKs in different languages, C#, Java, TypeScript, whatever, to help you work against those APIs. But we're really down at the metal here. We need to understand sometimes complex APIs and their relationships. I can't call API A on resource B until API C on resource D is completed. That can be hard to express in code. And sometimes, I need to add in wait or status check loops. This is something where the template approach really has the win, because it will do all the waiting for resources to stabilize before progressing to the next resource. With code, I don't have that. I have to do it myself. But, hey, I'm a developer, so working with service APIs to spin up cloud resources is pretty cool as far as I'm concerned. So here's one example of a template approach. This is a CloudFormation template. So here we're using the JSON format of a template. And here we're expressing our intent in a declarative manner, like what I want, not how to do it. Let's take a closer look at some other templates that I have that illustrate the template approach. So here's one where it's launching an EC2 virtual machine with what's called a wait condition. So it's waiting for the instance to stabilize because I want to run a script on it. And you can see that at the top of the template, I have some parameterization. I can pass in parameters to my template, so I can do some customization. And this is also how I can do reaching out into my environment to discover IDs of other resources if I've stored them in a key value store online, such as Systems Manager's parameter store. You'll notice that I can set allowed values for particular parameters, so I can restrict what people can enter. Scrolling a little bit further down, this template has a lot of parameters on it. Then I have the definition of the resources that I want. Here I'm declaring I want an EC2 instance or a virtual machine. It has a certain number of properties that I'm filling out. You can see here is references to the parameters. Again, it's a simple syntax, but it's a little bit more verbose than I would like. And here is an example of a user data script written inside a template. And you can see that it's just, here's one of the expressions, join. So this will join all these lines together with no delimiter to form the eventual script. And inside the script, you can see that we're referencing other resources inside the template. Again, it's reasonably simple, but it's kind of hard on the first pass to get it correct without typos and typing mistakes. Here's another example template. This is from a .NET sample application we have that we've talked about at our own reInvent conferences a few years ago, called Cloud Mosaic. And you can see that this is defining more resources for the stack, which is what the provisioned infrastructure is called. A database table, table gallery, another table, couple of tables. And then this just goes on and on. You can see it's quite a lengthy template. If I just scroll very, very quickly through this, it took a lot of time to develop this template and get it accurate and correct. Here's another example, this time dropping down to the low-level service API level. So this is a PowerShell script that launches an AWS virtual private cloud, so a private network hosting EC2 virtual machines that are going to run IIS, so Windows Web Service. And again, you can see I can parameterize my script. It's PowerShell, so that's what you expect. But this is using commandlets from the AWS tools for PowerShell to actually work with EC2 or work with AWS service APIs. So here I'm getting all the availability zones inside a region that I can launch EC2 instances into. I create a virtual private cloud. I attach an internet gateway so that traffic can reach my private cloud or my private network through the internet gateway. And you'll notice that when I create the gateway, I then have to go and attach it to my VPC. This is something the template approach does for me. I go through and add what are called public and private subnets. So public subnets are reachable from the wider internet. Private subnets are only reachable from inside the virtual private cloud. I then add on firewalls, what we call security groups. And you'll notice there's a lot of code in here just to wire up these basic resources. And you'll see where the CDK really adds value when we look at this example later on in CDK form. So let's go back to slides and start looking at the CDK and what it brings to the table. And let's start with, what is it? So the CDK, as it says on the slide, it's a multi-language software development framework for modeling cloud infrastructure as reusable components. Now that language can be TypeScript, JavaScript, Java, C# or Python. It's an open source project, so you'll find it on GitHub. And what it does, it takes your infrastructure definition written in code, in this case, in the example here, it's C#, and turns it into a CloudFormation template behind the scenes, which it then deploys out to CloudFormation. And you can manage the stack, as it's called, the infrastructure from the CDK command line. So here's another example of defining some infrastructure. Here we've got a simple notification service topic that's going to subscribe to a queue. And as messages come into the queue, it's going to fire off notifications. And you can see that in this example, we have some dependencies on namespaces related to the AWS service resources we want to use. These are just NuGet packages. Inside our app, we have a class derived from the CDK stack type. This defines our unit of deployment. Inside the class, we have what are called constructs. So SNS simple topic stack has a queue construct and a topic construct. And notice how that when we're configuring them, it's a natural flow in the code. There's no clumsy wire-up syntax. I just say, hey, add subscription to this object. We have available to us all of that power and expressiveness of the chosen language. Right now, this simple example doesn't show much, but you can imagine running queries inside real environments to say, hey, if this resource exists, do this, else do this, or other expressive statements. As I mentioned, the code is used to create a CloudFormation template that then gets deployed by the CDK tooling. Now, you don't need to pay any attention to the template unless you really want to. You can just continue to work with your whatever language your chosen language is. So we've seen a brief example there of a stack type, but let's see how this fits into the broader picture, right? So at the outermost level, we have what's called a CDK application. And that's the code that the CDK tooling runs to emit, or in CDK terms, synthesize a CloudFormation template that then is ultimately deployed. Within the app are one or more stack definitions. And as I mentioned, stacks are the unit of deployment. Each stack defines one CloudFormation template, and they're separately deployed. That means that if you want to, you can separate infrastructure concerns into different stacks. Now, I'm not going to do that in this particular session. I'm going to stick with just having one stack inside my demos, but it's certainly possible to have multiple stacks inside one app. Within each stack, we compose our infrastructure by using one or more constructs, and constructs map to cloud resources. Now, they can map to low-level CloudFormation resources, for example, say just a virtual machine instance, or they can be higher-level opinionated resources. Now, opinionated resources or opinionated constructs, they pre-supply certain reasonable or common defaults for some of the resource properties. Right. You can also group resources and constructs into additional reusable constructs, so you can compose your own constructs. Let's say, for example, that as a company, you have certain requirements that virtual private clouds or virtual private networks that you instantiate have to have certain configuration properties set by default. You can build your own construct that expresses that. Or maybe you want the VPC configured with additional resources. You can certainly define all of that inside a construct and then easily share that within your company or externally. So AWS provides what's called a construct library that has mappings to various AWS resources. And this has a number of levels. So at level 1 or L1, these are the low-level CloudFormation resources. They're called CFN resources, and you'll see in their names they begin with a CFN prefix. Now, with these constructs, you have to configure all the resource properties yourself. These are not opinionated; they are generated directly from the CloudFormation resource specification. Moving up the stack, we have L2 constructs. These are higher-level, intent-based. And these add the common defaults that you might want to work with and some useful methods. So, for example, on an S3, a simple storage service bucket, you can add a lifecycle rule using a convenient method. You don't need to go drop down to any low-level properties to do that. And L3 is what we call the pattern-based resources. These are the highest level abstraction. And these use composition to define additional, or to include additional constructs, usually with multiple coordinating resources, that make it really convenient to stand up entire levels of infrastructure with a single construct instantiation. Some examples you might typically see in demos are the application load balance Fargate service. It's quite a lengthy name, but the resources that sets up is actually quite extensive. Or you might set up a serverless REST API with a Lambda REST API. So that's a Lambda function, a serverless function, fronted by an API hosted in the cloud. As I mentioned, you can define your own reusable constructs. You can build your own construct library inside your company or to share it publicly. So what's the big picture then? How does this work together? So we take our CDK application, that's our source, and we run it through the CDK command line tooling, which effectively acts like a compiler. It emits the CloudFormation template, or the assembly language, if you like, of the cloud on AWS. And then you can deploy that template to CloudFormation, which is our runtime processor. That then spins up the infrastructure that's defined in the template. Now, there's the synthesize step that's mentioned here. That's something you can also run if you want to go and take a look at the template before you deploy. I also use that command, or that mode of the command, to do like pre-deploy compilation checks. Does everything check out okay? My code compiles, but is are the dependencies all correct? There's no cyclic dependency, etc. I can use synthesize to do that, and then you deploy as a separate step. But there's no requirement for me to run synthesize. I can just go straight from my source code to deploy to the cloud. So an overview of the main components of the CDK. We have the core framework, which is what's hosting your application with its stacks and its constructs, the construct library, and then your own construct libraries, which are not shown on this diagram, and then the CDK CLI. Now that's node-based or NPM-based, so that's for all languages. So even if I'm working with .NET or Java or Python, I do need to have Node installed to install the CDK CLI. So let's dive into some examples to see the CDK in action, and we're going to start with a simple one just to get us comfortable with the idea of using the CDK's command line. And what I'm going to do is I'm going to build a static website hosted in an Amazon S3 bucket. A very, very simple demo. I realize that, but it's a great one for just kicking the tires and seeing how things work. So inside this command, this folder, I'm just going to make myself a little, let's create hello world site. It's early in the morning here, Seattle. My fingers have not warmed up yet, so bear with me as I'm typing. I've already defined some static content for my site, so I'm just going to move that to where I am because I want it to be alongside my code. So there's my site contents, just a HTML page, but you know, you could be much more than that. Okay, so how do I get the CDK? Well, I mentioned it was mode-based, so install-g AWS CDK will install the CDK command line tools that you need. I already have them installed. I'm not going to run that, but once I've done that, then I have access to a CDK command line tool. And if I run that and just scroll up, you'll see it has a number of options on it. Lists, and we'll come to those in a minute, but CDK init. So I can get started with a CDK init command. And this is going to say, okay, there's a couple of templates that you can have pre-generated for you. I'm going to go with an empty construct, but you'll notice that there's a language switch. So I'm going to choose a C# example. Oops, I've got code in here. Hang on. I just need to prematurely move site contents back up again because you have to run this in. Okay, hopefully this is empty. Okay, CDK init. Let's just do that again. Okay. Okay, so that's added my CDK for sample. So now let's just move site contents back into here. All right, cool, ready to go. So I'm just going to launch Visual Studio Code on this, and we'll take a look at the files that we generated. So you'll see that there's a cdk.json file, and this defines, you'll see there's an app entry here. This defines the command to run. So the CDK will run this command to generate the template. And yes, you can do all of the dependencies for me. And there's some additional switches. We'll see context in a later demo. Inside there is a source folder, there's a solution, and inside there is a project folder. And if you take a look at program, close this window here, here is my top level application. So you'll see we instantiate an app, a CDK app, and then we instantiate something called Hello World Site Stack. This is going to be our infrastructure stack. It takes the application as a parent and then the logical name. And then you'll notice it just calls app.synth. This is what causes the template to be emitted. Inside my project, there is just a reference to the CDK core assembly. And then in the stack itself, you'll notice we do take a class and we derive it from the CDK stack class. That all constructs in the CDK instantiate with the same pattern. They take a scope construct, which is like the parent. Typically, this is always going to be the stack when you're defining inside the stack. A logical ID, now this is not the name of the resource. This is just a logical ID that you'll use to refer to it inside the code. and then optionally a set of properties that configure that particular resource. So let's get started with defining a website hosted in S3. Now, the first thing I'm going to want is an S3 storage bucket. So to work with S3, I'm just going to add a dependency on the S3 NuGet package for the CDK. And all of the .NET packages have the same naming format. Amazon.cdk.aws. In this case, S3, and version will be 186, or 187.0 now, a new one overnight. I knew there'd be a new CDK version. It ships quite frequently, and I had a feeling there'd be a new version before I even started today. So that's fairly cool. I'll update those later on. Close that window. So let's go back to our site so I can start defining our resource. So first thing I'm going to want is a reference to the namespace, amazon.cdk.aws.s3. And now that I have that namespace, I can create myself a storage bucket. I mentioned the common construction pattern, so I'm going to pass in this, which is the stack. That's the parent of the bucket. Let's just call it give it an idea of my site bucket. Will do. And I can bucket as optional properties, but I'm going to specify a couple because I need to configure this bucket as a static website. So to do that, you'll notice that here are all the different properties on the bucket resource itself, many of which, because I'm using an L1 construct here, it doesn't have the CFN previous line name, will have predefined defaults set for me. But the two that I want are public read access to be true. Right? No point having a website hosted if people can't get to the content. And then to configure an actual S3 storage bucket as a website, we just need an index document. And my site content I'm going to deploy, I'm just going to call that index.html. And that's it. For now, that's going to create a resource. So let's jump back to the command line and see how I work with the particular stack that I have. So jumping to here. So we're sitting in that top level CDK folder where I have the CDK JSON file. That's a requirement for this. Let's take another look at my commands that I have available to me. So we have list, which is it's useful if you're using multiple stacks inside an app. Synthesize, which will print the CloudFormation template. Bootstrap, if you're going to be doing deployments with the CDK, you can also do deployments as well as in standard infrastructure. You'll need to bootstrap first, so it has a storage bucket where it can put resources. I've already gone ahead and done that. Deploy is the one I'm going to use to deploy the stack, and so on. So let's take a quick look at CDK Synthesize. If I could type and spell, that would be really helpful. So that will now compile that code, run it, and emit the CloudFormation template. And you'll notice that, let me just scroll up here, you can see that there's the actual contents of the template that's emitted. And this is stored on disk. So if we take a quick look, you'll see there's now a cdk.out folder. We'll take a look at that in a moment. Actually, let's go do it now. Let's jump back into Visual Studio Code. Why not? Why not? So here's the CDK file, and you'll notice there's a template.json here. And this is the generated template from that code. So a couple of lines of code has expanded to, I don't know, over 100 lines of template that I would have to write myself ordinarily. All right, we have our template. Everything's looking good. So let's go ahead and deploy. And when I deploy, I'm going to give it my account or my credential profile to deploy with. And that will start to stand up the resources in the cloud. In this case, it's just an Amazon S3 bucket. Now, because I'm opening up an S3 storage bucket to people to have access to it, the CDK has detected that there are permission changes needed. And it's prompting me first, before I deploy, are you sure about this? People are going to need to do get object to read. Yep, I'm good. So let's just go ahead. And this will take a few seconds. So there's the bucket that I requested. You'll see it's of type AWS S3 bucket. That's how you would express it in the CloudFormation template. And you'll notice that I didn't give the bucket a name either. There was a property in the property bucket called bucket name, and that allows me to give it a fixed name. The thing with Amazon S3 storage buckets is that the names are have to be globally unique. So as this is an opinionated construct, it will pre-supply a name if I don't actually give it one. That makes working with buckets a lot more convenient. Okay, the stack is stood up. You'll see it emits the ID of the stack. Now we actually have a storage bucket. In fact, if I use a commandlet from the AWS tools for PowerShell, there is the bucket that just got created. And you can see that it's named after my stack and with some random characters on side to make it unique. So we have a bucket, but we don't yet have a website because we haven't deployed any code. So we need to fix that. So going back to the project and close off the template. I mentioned earlier on that the CDK can also be used to do deployments. So it has some notion of assets. There we go. So I'm going to add another reference here to a package. And this is called amazon.cdk.aws.s3.deployment. And this is typical if you're doing, as I'm doing here, a static website deployment, or it works with containers, Lambda serverless functions. It will actually take the assets, bundle them up, and then deploy them for you using different libraries. Okay, so that's built. So let's go and extend our stack a little bit further now and add in a deployment. Oh, actually, I need to make a new space first before I do that, using amazon.cdk.aws.s3.deployment. Okay, so now I can create something called a bucket deployment. And again, I pass in this for the construct, the stack, site deployment will do. New bucket deployment props. Okay. So what I'm going to want to do for this is I need to give it the destination bucket. And here I just reference the bucket. Oops. Bucket encryption. Bucket. There we go. So I don't have to take the name of the bucket. I don't take the ID. I just reference the construct that I just created. And then I need to give it the sources, what are called the sources of the assets to deploy. So in my particular case, I'm going to use something called source. This is a CDK utility, the asset, and I'm just going to point it at my site contents folder. Contents. Okay. That should do it. Like that one. Yep, that's fine. Okay. Sources. New source. I'm just checking against my notes because it's early morning and, you know, easy to make a mistake. Now, the other thing that would be really useful to know would be the URL of the bucket website that I'm about to stand up. So from stacks or CDK stacks, you can also emit data. So we have something called a CFN output. Now, this is an L0 resource. Remember the CFN resources I talked about? So we're going to attach an output from this, and we're going to call it site URL. And we're going to call CFN output props to configure what I actually want output. And in this particular case, I'm just going to give it a value. I can give it names as well. I'm just going to give it bucket dot, and it's called bucket website URL. Okay, finish that out. I think it should be good. So we've added 2 extra resources now: the bucket deployment, which is going to do some additional work, and then the CFN output parameter. So I'm going to get the URL of the bucket that's been constructed. So let's go back to the command line here. And one of the additional useful tools inside the CDK is you can diff stacks. So remember, I deployed earlier on and I created a bucket. Oops. Source.asset. Whoops. I knew I'd done something wrong. 1 second. Sources equals new iSource. What did I do here? What did I get wrong? The method, yes. Oh, silly, I've got the extra bucket in there. There we go. That's more like it. Okay, back to the command line. Good. Clear that out. Okay, so I was mentioning that I deployed the bucket earlier on. That was the single resource. Now I've added extra resources. Let's go and take a look at what the differences are using the diff command. And this can be really useful if you have large stacks. And of course, I need to give it my credentials, otherwise it doesn't know what existing resources I have. This can be really useful if you have large stacks, lots of resources, and you've made a small change. Maybe it's a permission change. Who knows? You can diff and say, you know, what am I actually going to get from this? So you can see that I added two things, right? The bucket deployment and a CFN output. But notice there's a whole bunch of additional fields in here. Here's the tab. Here's the bucket deployment, and so on. The way that the deployment works is it uses a Lambda function in the background. I'm not going to define that Lambda function. The CDK will define it for me. It's part of its opinionated constructs. So let's deploy this, and we'll see those extra resources get stood up. Okay, again, we're making security changes in here because we've got the deployment as a Lambda function, which has permissions associated with it. The first thing you'll see is publishing with some random number. That's actually taking that site contents, it's bundled it up, and it's sent it up to a storage bucket ready to be deployed to the site. Now it's making additional change to the stack itself to add a Lambda function that's going to take those assets and deploy them to the bucket for me. Now, this has been an easy thing to do using additional scripting, but when you're working with containers, Lambda functions, etc., this is a really convenient way of just working on site. I can just change those site contents, rerun the stack deploy, CDK will take care of it for me. So you'll see there's some additional resources now. We have a role. So that's the role that the bucket deployment is going to run under, what permissions that bucket deployment has to access that bucket. A Lambda serverless function that's going to do the work for me, which is the version layer. A policy that it actually defines the permissions that are going to be used to do the deployment. In fact, while that stands up, let's go and take a look at the resources. So I'm going to jump to the management console here, jump to the identity access management tab while that finishes. And if I go into roles, I'll scroll through all my roles, I should find the one for Hello World site. There it is, custom CDK deployment. You'll see that it says the Lambda basic execution role, so that Lambda can actually run. And then it has this custom policy attached to it. And if we look at the custom policy, you'll see that it's allowed to access my staging bucket to get those assets, the deployed site contents, and then put them into my storage bucket that I created earlier on. Okay, it should be almost done and deployed. So the next thing we're waiting for is for that bucket URL to be output, and there it is. Just in time to take a swallow of coffee. All right, so I'm going to take hold of this, and hopefully this will paste into one string. Then go to tab up here. Oops, go away. Yes, I know I'm sharing the screen. Go away. Take this out so I can get to it. New tab, that will do. Okay. .com. If I bring this up, we should see the Hello World website, static website. Get rid of that. Okay, so that's my deployed site, right? That was fairly easy. Let's go back to the code and take another look at what I did. So I created the bucket, adding a dependency on the S3 CDK assembly. Then I created the bucket deployment just to make things convenient, pointed it at my site contents, and then asked for the bucket website URL to be output from the end of the stack. We're going to take a look at the code or the template that was generated. You'll see that now it's expanded quite a lot, right? How many lines of code do we actually have inside here? So what, 30 lines of code with spacing. Here we've got a quite extensive template that's building up, doing my deployment for me. And you can see some of the, when I was talking about expression inside templates earlier on, you can see how complex expressions can get in just joining and selecting and splitting strings inside a template to get to the actual resources or the resource IDs, resource names you want to use. I mean, this is stuff, ignoring the CDK's quite lengthy names, this is stuff I really don't want to write, right? I'd much rather write this and then have it done for me. So that was a CDK deployment. Now, there's one other thing you might be curious about. Okay, I've stood up that stack. How do I get rid of it? Well, the CDK has a destroy command, and that will tear down the stack and all the resources for you, except the storage bucket. Now, when I created the storage bucket, I could have optionally set an additional property that said delete it when the stack is torn down. However, S3 has a rule that buckets that contain content cannot be deleted. And that's a good thing, right? I don't want to accidentally delete a production bucket. So this is not a bad thing, it's a good thing. So the CDK will actually leave the bucket intact. So I'm going to use a separate command to remove that bucket and do the full cleanup. But this will tear down the remainder of the resources. It tears down the deployment assets, the Lambda function, the roles, etc. Everything's gone. And now if I get my list of S3 buckets, there was the bucket that was created. And this is a quick tip for any of you that work with the AWS tools for PowerShell, knowing that you cannot delete a bucket unless you delete the content. There's a handy switch on remove S3 bucket that will do it all in for you in one hit. So super useful. All right, so let's move to the second example. And earlier on, I showed you a PowerShell script that stood up an EC2, a bunch of EC2 virtual machines in an autoscaling group in a private network to host a Windows IIS web server fleet. So I've put that into a CDK demo application. In fact, I've already gone ahead and deployed it this morning because it takes about 15 to 20 minutes for all the resources to stabilize. But I've taken it a little bit further. So let's go and take a look at the code and what I've done. And again, I've put this into one stack. Now this is an example where in the real world, you would probably have multiple stacks. You'd have one for the IIS web server fleet. You'd have one maybe for the CI/CD pipeline that I'm going to set up, and one for the deployment infrastructure. I'm going to use code deploy to lay my application down on the instances. To keep things simple today, I've got everything inside one stack. So here's my generated CDK application. And inside the program, we have just a simple app that stands up a single stack. If I look at the stack, let's take a look at what I'm actually going to do with this. So skipping past the entry here. So the first thing that I need is a new virtual private cloud, a virtual network, private network, to host my web server fleet. And inside the region, I'm going to have this fleet span 2 availability zones for redundancy. And inside each zone, I'm going to have 2 subnets, a public subnet, so traffic from the internet can reach my application or reach my network, and a private subnet, which is where my instances are going to reside. So my web servers are not directly accessible from the internet. This is a best practice. And you'll notice that I'm standing up the virtual private cloud here with this effectively a single command. This is another one of those higher level opinionated constructs. Remember when I showed you the, I think it was the cloud mosaic template earlier on when we started, there were reams and reams of template constructing a virtual private cloud. In the PowerShell example, there were reams and reams of API calls to set up a private cloud. Here it's just a simple VPC construct. Inside that VPC construct, I'm going to launch an auto-scaling group. So I'm going to ask for 1 instance to start, a maximum of 4. My instance type is going to be one of the free tier ones. And I'm going to start from a base virtual machine image provided by AWS. This has pretty much nothing on it, no custom software at all. I'm going to install everything that I need via a script as the instances start up. Now my instances are going to need some roles. They're going to need to have code deploy run on them, or the code deploy agent run on them to lay down the bits. Sorry, my mouse keeps popping over the tooltips. And I want those instances to be able to get to my Amazon S3 storage bucket where I'm going to put my application bundle. So I've added a couple of managed policies here to do that. I could lock them down even further to the specific bucket, etc., but I'm going to keep it simple today. And I'm going to wait. The autoscaling group is going to be configured to wait for these resources to stabilize before it brings a new instance into the fleet. So I'm going to do that with a signal. So here's my script to customize those vanilla EC2 virtual machine images. It's going to be a PowerShell script. You can see I'm going to install IIS. I'm then going to install a tool called Chocolatey, which is actually quite useful installing web deploy. Installing web deploy for an ASP.NET application can be a little bit grungy if you try to get hold of the MSI to do it. So using Chocolate is way simpler. Then from an S3 storage bucket, I'm going to download the code deploy agent, which I need running on the instance so that I can do deployments to it. Notice how much simpler and cleaner that is than in the example I showed earlier on where we had the user data script in the template. All right. Then I'm going to add a signal and exit command here. So when this script finishes, an extra command will be added to the end that says, hey, signal the scaling group that I'm stable and ready to go. The next thing I'm going to do, because this is going to be a fleet of instances, I need a load balancer. So here I'm going to instantiate an application load balancer. And again, very, very simple construction, high-level opinionated constructs that supply many of the default set. It attaches to my virtual private network, or it runs inside that VPC, and it has internet facing turned on, so people can reach it from the public internet. The load balancer has a listener for port 80, and that's going to have a set of targets attached to it that say, hey, anything traffic coming in on port 80, forward it to my scaling group, and that will automatically then reach my instances. And you can see I'm allowing port 80 from anywhere, open access to port 80. The next thing I need, that finishes my fleet. That's it, right? That entire PowerShell script that we looked at earlier on is encoded in just those few lines of code. Next, I need some deployment resources. So what I'm going to do is I'm going to build web deploy, an ASP.NET sample application, build it as a web deploy package, upload it to a storage bucket, and have it deployed to the instances from there. So I want to get onto a new, put my teeth back, a new S3 storage bucket. Then I'm going to set up a code deploy application, and you'll notice here that this looks a bit weird. Well, what's this node try get context? Well, this allows me to pass in values to the stack when I build it, when I deploy it, that customizes some of the names. If I look at the cdk.json file here, you'll notice that I have these additional context switches. They're just key value pairs at the end of the context. So these pre-supply some defaults. Now, when I run CDK deploy, I can give a -c switch and override these values, simply with key equals value. Here I've put them into the context file itself. Sorry, the context entries in the file itself. So here I'm going to get the name of the code deploy application and deployment group that I want to have specified from the context, create a code deploy application, then create a deployment group that is targeting my auto scaling group. So all the instances inside that scaling group will have the deployment performed to them. I can optionally have the agent installed, the code deploy agent. In this case, I've already done it as part of user data, so I've turned that off. And then, again, permissions role that allow code deploy to reach my instances. And then the final thing that I've set up is a deployment pipeline. So rather than me have to go and manually fire up a code deploy, I've taken advantage of the CDK's code pipeline actions libraries or pattern libraries to add a CI/CD pipeline that is triggered by me uploading new bundles, new web deploy bundles to my S3 storage bucket for this particular CDK stack. So here I'm pointing at my deployment bucket where my bundle is going to go. And if I write a new object to that bucket, I upload a new application bundle, that's going to fire an event. That event is going to trigger the code pipeline to run. And then here's the code pipeline itself. It triggers off the build upload. That will then trigger the next step, which is to actually deploy that bundle using a code deploy server deploy action. So this is a really convenient way of setting up CI/CD pipelines using the code pipeline service. I could also add custom builds in here using code build if I wanted to go and build the bundle. So I could take, for example, the source code from GitHub using a GitHub action, have it built, and then deploy to the instances. But here I've already pre-built the bundle. I'm just going to upload it to S3. So that really is my app. And at the end, I've got some outputs that tell me some of the resources that I'm going to want to use. So let's go and take a look at the actual deployed application. Let me get back to my command line here. So here is the outputs from here. You can see here's my Windows Web Server Fleet load balancer URL. So I'm going to copy that. And let's jump to the web browser. And if I paste that in there, we should see IIS's homepage. Cool. Now, if I go to /sample, which is where the application is going to be deployed, that's the way I've configured it, we should see a 404. Right, so the application is not yet deployed. Cool. So what I'm going to do next is go and look at this stack very briefly. And here's my web server fleet stack that I've deployed. And if I go to resources here and scroll through, you can see all the individual resources I've created. So there's my application deployment bucket, my fleet stack, some roles, defining the permissions that the various resources in the stack can use. AWS has a very fine-grained permissions mechanism. It's possible to define a role that has policies on it that permit access only to certain APIs on certain resources or that involve certain resources. And we start from a position of nothing is allowed. So you build up the permissions that you need rather than take them away. If you're not familiar with the way we do things. Here we can see that the security groups related to EC2, that's the firewalls, and so on and so forth. So a whole bundle of resources there got created inside this stack. So how am I going to deploy to this? Well, I'm going to cheat a little bit. Actually, let me go to code pipeline before I do a deployment. Here's my pipeline. Initial one failed because there's nothing to deploy. Hopefully, let me just check the details here. That yeah, that's fine because I've not yet uploaded anything. That's cool. I'm good with that. Other people might not be, but I'm good with it. So let's jump back to Visual Studio Code. And what I've done is inside the README here, all of these files are actually up on a GitHub repo. I've pre-written the command that I need to do the upload. So inside here is a sample app folder, and inside there is my pre-built web deploy bundle. So I'm going to use again the commandlets from the tools for PowerShell to actually deploy that bundle. All I need is the bucket name that I need to upload to. Now, this is an example of where you might do something. Let's say because this CI/CD pipeline isn't doing the build of the app, which would be a normal way of doing things. I'm kind of cheating and shortcutting a little bit here, but it's a perfectly valid way to do things. If, for example, you have an existing CI/CD setup and you just want that last mile to get to AWS, just build your application, put it into an S3 bucket, and then use the simple CI/CD pipeline to do the deployment. Okay, so I have my command. There's my bucket. It should upload. Done. Okay, and now if we access the pipeline, go back to my pipelines, it should sign this pipeline is now in progress. You see that the bundle upload is already triggered. It detected that S3 upload of the new app. Now it's calling code deploy. If we go and take a look at code deploy, we can see the deployment should be underway. Yep. If I scroll to the end and go to events, in fact, it's already done. It's finished. Here are all the events on the instances as it laid down those bits on the fleet. So now if we go back to our app, we should see, and don't get excited, this is just a simple ASP.NET application generated from a Visual Studio template, nothing else. You'll see it's taking a little bit longer to start up as it cold boots on the instance in the IAS. And there's our simple app, and you can see that serving it from an EC2 instance at the bottom here. So a very simple CI/CD pipeline allied to a web server fleet inside a virtual private network. Let's go back to the code to finish up. And again, I just want to review the code that we have here. So here's my stack, and remember that I'm going all the way to the top. So we created a virtual private network with an autoscaling group with a fleet of EC2 virtual machines inside there, configured on the fly from stock images supplied by Amazon. Added a load balancer. Then we added some deployment resources, a bucket to put our application in, our application bundle in, code deploy resources to deploy those to the instances in the scaling group, and then a deployment pipeline using the code pipeline actions library inside the CDK that just took care of the deployment once I uploaded the bundle. So that came in at, let's see, around, all right, ignoring spaces, 230 odd lines of code. This is the template that was generated from that. And this, I think, is a huge illustration of the time saver that the CDK brings to the table, the time savings it brings to the table. This template, which is JSON, is over 2,000 lines. Okay, so that's 130 lines to 2,000 lines. It saved me. CDK is a huge time saver, in my opinion. If you haven't tried it out yet, I really encourage you to go give it a check. So that brings us to the end of the demos. So a quick recap in this we have left. So we took a quick look at the start at what have we done with IAC or infrastructure as code to date, using declarative templates, consoles, scripting, etc. What works, what does not, the problems that we have. Introduced the CDK, the concepts it has, the command line tools that it has. We have .NET bindings for the CDK. They're just a collection of .NET standard 2.0 NuGet packages with consistent naming. You find them on NuGet. You can build your own and distribute those. And a couple of examples, the simple website host on S3 to get us started with kicking the tires with the CDK command line, using constructs in a stack, how to structure the applications, etc. And then a slightly more involved demo, the Windows IIS web server fleet, and having a CI/CD pipeline set up for us. A very simple one, albeit, but a very useful one. Okay, some useful resources. All of the session samples that I used today, and there's some more from other CDK talks that I've done, can be found at that GitHub repo. I will also upload the deck into a decks folder later on. CDK Developer Guide and CDK API Reference are your go-to resources for learning about the CDK. In fact, I have the API reference up. Let me bring it up here. So here's the CDK API reference. You can see that all of the construct libraries are defined in here. So one of the ones we used today was autoscaling. The definition of autoscaling group gives you all the properties, etc., all the methods on those individual constructs that you need. This is my go-to resource for finding out what I need to set up. CDK itself, as I mentioned earlier on, is open source. You can find it on GitHub, github.com/AWS/CDK. And there's also a samples repo on GitHub as well. So with that, thanks for coming along and listening. I hope you found that useful and intriguing, and feel like you want to go and check out the CDK. Invite you to follow me there, and also invite you to follow .NET on AWS. We have the .NET on AWS Twitter handle. That's where we make all our announcements, things that we find of interest, etc., etc. The usual Twitter stuff. You know how it goes. Okay, so with that, if there are any questions, I didn't see any in the chat window get entered, so I'm guessing there are no questions. That brings me to the end of the presentation. Again, thanks for listening. Hope you found that useful. If there are any questions,